The next thing that we will be discussing is the overtaking side distance. Okay, overtaking side distance is nothing but the side distance which we need to maintain when we overtake a vehicle. Okay. Now, what is happening in case of the overtake? That we need to understand first. So, when we overtake a vehicle, there are three things that will be coming into it. Okay? First one, say this vehicle is going to be overtaken by another vehicle A. Okay. So, here, first consider the condition for single lane two-way. Okay, single lane two-way. That means the vehicle will be coming from both directions. So there will be another vehicle C present over here. Okay. Now the first thing is that these vehicles are moving in this direction. So when A is having a greater speed than B, then only it will be able to overtake. Alright? When this vehicle A will be having a greater speed than B, then it will overtake B. Okay? Now, the first thing is that before overtaking, that will decide if the vehicle needs to have a greater speed or not, or in other words, if the vehicle is in the speed, say design speed, okay, then if it needs to accelerate or not. Okay, so there will be some time for that, which in which it will decide that, well, I have to overtake the vehicle, so I will have to accelerate, and in this way I will be overtaken in this path. Okay, and no vehicle from the other side is coming in this way. Okay, so that distance is considered as V1, which is equals to V into E. Okay, where V is the design speed and this E again is the reaction time, generally considered as 2.5 seconds. This distance is D1. Okay, one component we already have, D1. The next component will be D2. D2 is the distance traveled. D1 is again distance. D2 is also a distance, because we are ultimately trying to calculate overtaking side distance. This D2 will be equals to the distance traveled when this vehicle is actually overtaking this one. Okay, which is equals to 2s plus 1, 2s plus d1, or you may take it as, or in a simplified way, another factor coming from empirical equation, dA, axle, the velocity of this vehicle dA, into T. T is the capital T, not the reaction time. Here, this capital T is nothing but the time taken to overtake. And this A is the acceleration when the overtaking is taking place, into T square, because in acceleration the unit is meter per second square. So in order to get distance, we are trying to square this time. So this will cancel out and it will come as meter. Okay. So 0.7 df into t plus a into t square. This is d2. Okay. Another part will come which this vehicle will travel in the entire time when this overtaking is taking place. This overtaking is taking place in t time. Okay. So t3 equals to velocity of this vehicle v c into t. Generally we consider that dc or this v as the design speed. Okay. This one is also, sorry, this is vb, actually the distance traveled by this vehicle, because when the overtaking is taking place, overtaking जब हो रहा है, ये गाड़ी में तो आगे की तरफ जा रहा है, ठीक है, और इसको यहाँ तक पहुँचना है ओवरटेक करने के बाद, क्योंकि ये गाड़ी ओवरटेकिंग के टाइम पे यहाँ तक पहुँच जाए. So vb into vb is the velocity of this vehicle vb, this v. Okay, so here vb into t, time taken for the overtaking operation, and a into t square, acceleration of this vehicle into t square. A is acceleration. Okay, acceleration, a is equal to acceleration of vehicle A for overtaking. So this condition is overtaking side distance. This OSD equals to d1. So this OSD, overtaking side distance total, is equals to d1 plus d2 plus this one d3. This is the total overtaking side distance. Alright. Now this is for two lane two way. So for two lane single way, obviously not two way, single way, OSD or overtaking side distance equals to d1 plus d2 plus d3. If it was two lane two way, then OSD would have been only d1 plus d2. टू वे के टाइम पे क्या होता है, ये जो ऑपोजिट डायरेक्शन से जो गाड़ी आ रहा है ये प्रेजेंट ही नहीं है, ठीक है. So this would have been would not have been considered for two-way roads. For two-way, the vehicle from opposite direction absent. So d3 would have been equals to 0. ये समझ में आया सभी को, ठीक है. तो d3 जो वैल्यू वहाँ पे 0 होता तो सिर्फ d1 plus d2 रहता, ठीक है. So this is your entire overtaking side distance. Overtaking के टाइम में भी थोड़ा साइड डिस्टेंस मेंटेन करना पड़ता है, ठीक है. जब ये ओवरटेकिंग साइड डिस्टेंस कैलकुलेशन होता है, तीन कंपोनेंट रहता है. पहला है d1 जो कि ये व्हीकल ओवरटेक करने से पहले जब डिसीजन ले ओवरटेक करना है कितना दूर तक जाएगा, दैट इज द रिएक्शन टाइम ऑफ द व्हीकल. देन d2 when the actual overtaking is taking place, this vehicle will travel, the vehicle which is being overtaken will also travel, so that is your 0.7 into vb into t. Okay, and the next part is the overtaking operation, the distance traveled during the overtaking, that is a square into t. ये जो ये vehicle यहाँ से लेके इधर तक पहुँचेगा, ठीक है, यहाँ पे a into t square होगा, ठीक है. t square का मतलब क्या है, क्यों स्क्वायर लिया है, क्योंकि ये एक्सेलरेशन है मीटर पर सेकंड स्क्वायर, in order to get the distance meter per second square into second square, and this capital T is the time taken for overtaking. Okay, and small t is your, as written over here, reaction time. Okay, दोनों में अंतर है, दोनों को सिमिलर मत समझना, ठीक है. And third part is the V3, when the vehicles from the other directions are coming during that overtaking. Okay, that is why it is T, capital T into VC. VC is the velocity of this vehicle, which is equals to the design speed of that road. Okay, design speed हर एक road के लिए अलग-अलग होगा, ठीक है, depending on the different type of conditions like the geometry of the road, that the slope is present or not. Then we may have the things like the different type of school zone or hospital zone might be present. Okay, so in those cases we will need to consider the design speed only. So design speed will be taken in all the cases. Only here